Okay, class, let's take a look at an example where we can use these double angle formulas as identities to help us solve a trig equation. So if we take a peek at our double angle formulas and we look at this equation, this looks most similar to what's going on with the sine of 2 theta. So the double angle formula for sine, all I have to do is multiply it by 2 and it looks just like this identity. So I'm going to rewrite this as 2 sine theta cosine theta equals 2 times -1/2. Okay, so now we'll just substitute the left-hand side, this identity, and call this a sine of 2 theta equals -1. So as the sine of an angle is -1 when that angle is 3 pi over 2. So we're going to say that 2 theta is equal to 3 pi over 2. And then remember that it's true for every period from that point on. So if I add a full rotation to that, so where k is an integer. Okay, and the only issue now is that I want to know what theta is, not what 2 theta is. So I can divide by the 2 now, everywhere. And I get in terms of theta, it's going to be 3 pi over 4 plus, this is reduced down to just k times pi. Okay, so we're just going to run this through several values of k to make sure that we get answers that are between 0 and 2 pi. And if we start at -1, you can see what happens there. So this is our k. So that's going to be 3 pi over 4 minus 1 pi. So I'll write the 1 as a 4 over 4, so we have our common denominator. And that would give me a -pi over 4, which is below our 0, so we're not keeping that, but we're going to move on to a k of 0. So our angle then would be 3 pi over 4 plus 0 pi, of course, which is 0. So we just get back to 3 pi over 4. But that one comes in range here, so we're going to keep this guy. And we're going to move over here and use the k of 1. So theta would equal to 3 pi over 4 plus 1 in the form of 4 over 4 times pi. So 7 pi over 4. This is also within our range, so we will keep that. And if we let k move on to 2, I think this is good. We're going to exceed this at this point because we're going another another half rotation round, and we were pretty close to a full rotation, so this will be too large. Alright, I'm making k2, so I'm going to write 2 as 8 over 4 to keep the common denominator, and sure enough that becomes 11 pi over 4, and that's beyond 2 pi, so we're done. And we don't have to look any further. Our solution between 0 and 2 pi is 3 pi over 4 and 7 pi over 2.